we're going to shift gears a little bit, and instead of talking temperature, we're going to actually start talking about energy, and more specifically thermal energy or heat. This is our second subject that we were going to start to investigate. So when we talk about thermal energy, we've already talked about temperature, we now want to talk about thermal energy. We want to be able to relate the two. Is it possible to even? So we ask ourselves, how do we change temperature? Well, the simple answer is that if we give more thermal energy to the system, then the temperature should rise. If we take away energy from the system, then temperature should fall. So adding heat or taking away heat from the system will cause the temperature to change. Through experimenting, we've come up with a fun little equation. It's pretty easy to use. You've probably seen it before. It says that the heat related, or the heat needed to change an object's temperature by a delta T, a change in temperature, is related to the mass and this constant C. So delta T is the change in temperature, mass is the mass of, or M is the mass of the object, and Q is the heat energy, and C is a material constant. It's a material constant, and actually it's a phase constant. So to change 1 kilogram, 45 degrees Celsius of ice, you'd have to look up this value. This material constant is called the specific heat. So we look up the specific heat of ice, and it would tell us how much energy is required, or how many joules of heat we need to add to the system to raise it by that temperature. If instead of using ice we change to water, well then water is going to have a different material constant, a different specific heat. So you have to be careful to make sure that you're using the right material and the right phase for this, and that'll get you towards the right heat that you need. And even that is not necessarily true. These specific heats can vary slightly based off of the temperature. So depending on how accurate you need to be, you may have to use different values of C. One thing that should be noticed is that in saying that there is a specific heat, it's implying that this temperature change is only for one phase. If you go through a different phase, you go from ice to water, go from a solid phase to a liquid phase, well then you have to worry about the phase change, and we'll cover that in the next subject. So just be careful that you can't just go ahead, and a lot of students make this problem where they will just say, I'm going from one temperature to another temperature, and they forget that they're going from one phase to another. You have to be careful to make sure that this temperature is all within the same phase.